Hello, my name is Rohit Sinha, and the title of my poster is A Step Towards Zero Silicon Bugs Using Assertion Based Assumption Validation. And my co author is Babu Christie. Okay, so to quickly go into what is the motivation, right? Why exactly this whole idea has come into the implementation. So basically, as you see in the SoC, we have more than 1,000 IPs, both belong to external as well as internal, right? And when we have so many IPs and we have so many stakeholders in the SoC design, like DFT team, MBIS team, tab, debug, visa, like that, right? So basically, collating all the IPs and integrating with all the functional aspect of it, the CDC sign off become a very difficult task, right? And also we know, right? I mean, CDC RDC closure, basically this is very error prone because we have huge number of waivers, huge number of constraints, and the interpretation of each constraints are also not well understood with the knowledge base, with the low skill set design engineers at times, right? And also we know, right, the silicon respin, because of these meta stability issues and glitches issues, right, it's very costly. So idea is to basically build a robust automated flow wherein we can do a high coverage analysis for the CDC or RDC sign off, right? So to give you some design data, right, in our design there are more than 61,000 waivers, right? I mean, you can see the huge number of waivers, and the number of constraints are almost half of them, like 32K here, right? So here, I just to give the design background, right, the number of abstract models we are handling is like 300 plus. Similarly, the number of number of other collaterals, right, that also is so high, right? So going back to the idea, right, what exactly we are talking about. So basically we are talking about a mechanism wherein the CDC assumptions can be validated, right? And when we say CDC assumption, it means all the CDC constraints which are actually used for the analysis or the CDC closure that have to be validated. So as a first step, from the flow, you can see, right, the first step is to define all the waivers and make it in corresponding constraints, right? And then you do your vanilla flow wherein you do the structural check for CDC RDC, right? but the but the next step, right, you actually generate all the CDC constraint equivalent SVA, right? And those SVA have to be binded in your simulation environment. This is where we are going to add these assertions and in the simulation test benches, and then it's going to get validated, right? So and then you need to, once it is binded and the tests are run, right, then you check whether your assertions are actually hit or not. It means the assertions are being analyzed or not. If it is not analyzed, then go and fix your test, right? Sometime you need a specific test. For example, all the reset paths can be validated in boot ROM test. Similarly, the cluster based tests are there, right? So next thing is, if it is actually, if assertions are hit and then all the assertions are passing, right? If it is not passing, then you check for the failure, check for the initialization issues, right? And then you actually, the whole idea is you have to ensure the coverage of those assertions are high, and unless the coverages are not high, you have to fine tune your test benches and the simulation environment. So that's the reason it is a three-step flow, as I mentioned in this right hand side: the conversion, the generation, and the validation, right? So as I said, the constraint, the first step is to identify all the constraints. So basically we have to categorize all the waivers and make it an equivalent constraint. So we actually reviewed all the general waivers which are used in the design, and then we identify which are the constraints which can be used to cover these waivers, right? And the reason it's done, because basically the design intents are captured. Now you don't have to review because there will be SVA which can get validated, and the runtime of the CDC is vanilla run, CDC structural run, that also becomes much lower, right? So that's the main advantage of this. So going forward, you know, we need to understand, for example, as I mentioned in the last slide, all the assertions, all the constraints, right? You have a purpose why it is done, and then you generate on the right hand side, it is talking about each assertions which are actually generated. So you can check in the S3 file which are generated and then get analyzed, right? So again, as I talk implementation and flowchart, the way it is done, right? First, you need to create a library, assertion library, CDC assertion libraries, right? Which can be used and plugging into the simulation environment. Then you actually plug into the simulation environment, put the Verilog files and include those, right? And the last one is, once it is done, you should put it in a part of the regression so that it keeps running and your failure report and the coverage can be generated and in a regular manner, right? So if you see in the last, some of the messages I have put, those are like, for example, quasi static, the 88 85 attempts, out of that the 881 are successful, one are incomplete. Like that you get the coverage, right? For example, quasi static, reset filter path, this is just to showcase that, this is how the coverage reports are provided, right? So coming back to the results, I mean, so you can see the waveform. You actually identify some of the, for example, set case analysis is not holding good, or your reset path is actually, there is the order is wrong, or sometimes your quasi static signal is actually not quasi static, right? These kind of issues can be upfront flagged, right? To summarize the poster, CDC assumption validation is a mandatory, it's a must requirement, because this is how you actually validate your CDC assumption. It actually uncovers a lot of corner cases, right, which is impossible through manual reviews. Then binding the into the regression, it actually helps in reducing, it's a automated flow so that you can see the coverage in the dashboard much easier. It will reduce your turnaround time, right? Assertion coverage data also ensures your sign of quality, right? Then you can be more confident that your actually all the assertions are covered, right? So the main challenge is the identifying the correct test, and once the tests are identified and those assertions are hit and validated, with the confidence will be much more. So, and as a per the future enhancement, this SVF assertion should get validated using the formal technology, so that you don't have to go and tweak your test benches. So that's all from my side, guys. Thanks a lot. Thank you.